Hey guys, welcome to the VBA task for BFC3540 for week 2. So this week we'll be looking at a couple of different things, including how to refer to cells using the range dot command, looking at for loops, and also I'll show you a couple of debugging tools that we can use in order to help us program and understand VBA. So first of all, we'll go to the Range.Cells worksheet here. And this is a different way of referring to cells. So in previous weeks, we referred to cells using the range.value command. So for example, if I write a sub, and call it sub write to cell, and let's say I want to write hello to this cell right here, A5. So in previous weeks, what you would have done is range A5 dot value is equal to hello. And of course we use quotes because this is text or string data. And if you press play, you can see that hello appears in that cell. Now let me clear that. You can clear that by setting it equal to that, just an empty string. And let's start again. So instead of writing range.value, what we can do is actually use range.cells. Now range.cells is very, very useful because it allows us to refer to other cells using one particular cell as a reference. So for example, if I do range.cell, range, and then A5 dot cells, and let's say we do 1 equals hello. Let's see what happens when I play this. It goes into cell A5. Now remember how arrays in VBA are counting starting from 0? With cells, it's actually a bit different. So with range.cells, you actually count from 1. So what this here tells you is go to cell A5, so that's go to A5 right here, and then you count in by 1 row and 1 column. So essentially you start at cell A5 and you set that cell to hello. Now, say I wanted to set this cell right here to hello. There's two ways that I can do that. The traditional way, or the way that you've been doing it so far, is to just do range D8 dot value is equal to hello, right? So you know about that. You know that you can do range D8 dot value is equal to hello, and this will put hello into that cell right there. But that's not the most efficient way to do it. Well, for this task it is, but when you get into for loops, you'll see that it's actually not. So another way that you can do this is, let's say, instead of referring to this as cell D8, how about we try and find what this cell right here is in reference, or sort of, I guess, relative to this cell A5, okay? So let's delete this for a second and we'll do some counting. Okay, so let's say that we still want to use cell A5 as our starting point. So we'll go range A5 dot cells, and then we need some sort of row index. So remember that it's always rows by columns, whether you're working with cells, whether you're working with arrays and stuff like that. Except with cells, you start counting from 1. Okay, so what's the row for this cell right here, D8? So starting from A5, this is row 1, 2, 3, and 4. So you go across 4, right? So the row index is 4. Now the column index is 1, 2, 3, and 4. So you go across 4 and down 4 to get from A5 to D8, okay? So it's 4, 4. Now, what's really good about this, I'll show you here, is that when you actually open the bracket, it tells you, so it reminds you that it's row index, column index, so you don't even have to remember that it's rows by columns. You can just look at that and go 4 by 4, okay? And we want to set that equal to hello as well. So if we run this, you'll see that hello now appears in this cell right here. So what we can do is we can set all of these cells equal to hello just by referencing them relative to cell A5. Now that's a really useful concept, as you'll see when we go into the stuff on for loops. So you can do the same thing for all these data down here, except with these ones, you're working with numbers. So these are double precision numbers, decimal numbers. So you don't use double quotes, but that's the only real difference between this task and the task up here. Now, if we go into for loops, we can really see where this starts becoming useful. So let me make this bigger. So let's look at this first task right here. So in this first task right here, what we have to do is count from 1 to 10 and output the values into these cells. So in the yellow cell right here, you can make a prototype, and all you have to do is, that, and you'll have Excel count from 1 to 10 for you, okay? But now let's say you wanted to do it in VBA. Let's go to the For Loops 1 sheet on the VBA workbook, and I'll show you the syntax of a for loop. So we'll start by writing a sub, as we always do, okay? Now the syntax of a for loop is for I is equal to 1, 2, and here 10. Okay, so that's the syntax of a for loop. So what this here is telling us is that for some count I is equal to 1 to 10, it'll repeat what is inside the for loop again and again and again until I reaches 10, and each time I will increment by 1, okay? Now, let's say we wish to write some code in here. So what we want to do is we want to put the number I into that particular cell starting from cell A7, okay? So let's say we begin with writing what we want to put into. Okay, so we're beginning with cell A7. Now, do the rows change? Yes, the rows change because we're going down by one row with each and every iteration, right? So we want the row index to be I. So for the first iteration, I will be 1, so 1 in row 1, and then row 2, and then row 3, so on and so forth until row 10, okay? Now, do the columns change? No, they don't, because you're staying constant. You're staying in the same column. So the column will always be 1. The column of this one, this one, this one, this one are all the same as the original cell A7. So you want that to be 1. What do you want it to be? You want it to count from 1 to 10. So you essentially want it to input whatever the value of I is. Now, if I run this, you'll see that that'll input 1 to 10 here. So let's do that. And you get 1 to 10, right? But let's have a look at how this code actually works. So, in order to see how this code actually works, what I can do is I can set what is known as a breakpoint. That's really easy. All you have to do is click here, and it highlights that in red, which means that when the code gets to that particular stage, it'll stop there and allow you to step into the code and really see how the code works. Now, step into is given by this command right here, but you don't want to click on that every single time. So all you have to do is use the key F8 on your keyboard. And now let's see what happens. Actually, before I do that, let me just make the cells blank again. Okay, so you can see that the cells are blank again, and I'll change that to I. All right, and put the breakpoint in, and let's press play. So you can see that it's highlighted in yellow here. This means that that's where the code is up to right now. Okay, so first of all, if we put the cursor over the letter I, we can see that it says I is equal to empty. At this stage, the for loop hasn't yet run, so I has no value, okay? Now, we press F8 and we step into the loop, okay? So the loop has started now, and if we put our cursor over the I, you can see that I is equal to 1, okay? So essentially what this command right here is doing is it goes Range.A7.cells 1, 1 is equal to 1. And that's this cell right here, A7, and it'll set it equal to 1, okay? You can hover over this I right here, and you can also see that it's equal to 1. So essentially, it's just substituting I is equal to 1 into that line, okay? Now, go to the next stage, and you can see that it's input the number 1 there. Now here, I is still equal to 1, but next I tells VBA to go to the next value of I, which is I is equal to 2, okay? So let's say we do that, and you can see here, if you highlight any of these I's, it's all the same because I is just one value regardless of where you highlight. You can see that I is now equal to 2. So as you go into this command right here, what it does now is Range.A7.Cells, and it substitutes I is equal to 2 into this command. So it'll go Range.A7.Cells 2, 1 is equal to 2. Now, Range.A7.Cells 2, 1 means you're going down 1 and across none, because it's still 1, right? So if you go down 1 from A7, you get to A8, okay? So that's Range.A7.Cells 2, 1 is referring to cell A8, and it's going to set that cell there equal to I, and I is 2, okay? So if we press F8, we can see it input 2 into there. And then if you keep doing that, you can see it goes 4, 5, 6, 7, 7, so on and so forth, right? Now, let's say we're up to here, and we want to know what the value of I is. Let's think about that for a second. So you've just input the value 7, but you haven't run the command of next I yet. So where it's yellow, it means that is the command that is about to run. So that is the command that will run when you press F8, not the command that has already run. So it's the one that's next up, so to speak. So if you've already output 7, but you haven't gone next I, it means that I is still 7. Let's check if that's the case. And of course, I is equal to 7. Now if we press F8, this will change I is equal to 8. And then once we run this command, it'll input 8 into cell A7.Cells 8, 1, which means we're just going down 8 cells, and it's inputting the number I, which is 8, into that cell. Okay, so if we continue doing that, we can see that that is the end of the program. So as you can probably see before, once I reaches 10, which is here, it doesn't go back, it just goes into the end sub because it moves on. Okay, so once I reaches 10, which is the condition, it no longer goes back into the loop. Okay, now let's move along. With this, I guess, set right here, this is very similar to this, except what you're doing is you're no longer changing the row, but you're changing the column. So you can see here all the rows are the same, but the column's different. So the code will be very similar to this, except what you're changing, what the I is now the column, not the row. So the row will be 1, and the column will be I. Now with this task over here, if you're going diagonally, what you're actually doing is increasing the row and the column by 1 as you move along. So it'll be basically I, I. So this cell right here is A7, 1, 1. This cell right here is A7, 2, 2. This cell here is A7. Hang on, I realized I just made a mistake. So this cell right here is 07, 1, 1. This cell right here is 07, 2, 2. This cell right here is 07, 1, 1. This cell right here is 07, 2, 2, 3, 3, 4, 4, so on and so forth. So you can use the for loop to implement that. Now be really careful. Of course, this code is specific to where you start your counting. So this here starts at cell A7. So when you write the code for this set here and this set here, you have to make sure that you set the starting point what you want, where you want to start outputting. Okay, now let's go on to the next part right here. So you want to write a program that will count from 2 to 11, 5 to 50, and 3 to 30. So essentially 2, 3, and 5 to 50 is 5, 10, and 3 to 30 is 3, 6. So that is exactly what you want to output. Now, so with this loop right here, we used I is equal to 1 to 10, okay? For this right here, this is going to be really easy. It's just exactly the same code, except you want to start in cell A21, and instead of going I is equal to 1 to 10, you want to go I is equal to 2 to 11, but with a catch. So now moving on to this is really easy, the first one anyway. So instead of outputting I to your cell, essentially what you're outputting here is I plus 1, right? So essentially instead of outputting 1, 2, 3, 4, 5 as you have here, all you're doing is outputting 1 greater than that. So you can output I plus 1, I plus 1, I plus 1, and it'll be 2, 3, 4, 5, 6, okay? Now have a think about this. If you're outputting this, what is this really? That's the 5 times tables, right? So what you're outputting is 5i, right? So I'll do this one, and then you can sort of just apply that to the others to see how you can output multiples or additions or whatever the case may be. So let's write a new sub. And in this sub, it'll be for I is equal to 1 to 10, next I. So it's always good to start with the right syntax. So you write in the syntax for a for loop, which is for I is equal to whatever, and then end with next I, okay? Now it's 1 to 10 because we have 10 values. Again, it's very similar to this in that we start at a particular cell and we count down, okay? So we know that it has to be something that looks like this. So it'll be range. This cell right here is C21. And it's I, 1 because we're moving down and not across. So the row is what's changing. It's going from row 1, row 2, row 3, row 4, so on and so forth. But the column stays constant. And then what is this equal to? We want this to equal 3, 6, 9, 12, 15, and so on and so forth. So that's the 3 times tables. I think I said that I'd do the 5s, but it doesn't really matter. You get the point. So this is the 3 times tables, okay? So in order to get 3, 6, 9, 12, and so on and so forth, essentially you're no longer outputting I, but you're outputting 3i, right? So 3 times I. So if you do 3 times I, you can see that when you run this code, and let's put a breakpoint on it so we can see what happens. Let's run this code. Okay, and it's output 3 here, and this is why. So here, if we highlight I, we can see that I is equal to 1. So it's substituting I is equal to 1 into that formula, right? So you get range C21.cells 1, 1 equals to something. So what is range C21.cells 1, 1? That is cell C21, right? And it is setting that equal to 3i. So I is equal to 1, so 3i is 3. And then we're going to the next stage. Now I will be equal to 2, right? So what is range C21.cells 2, 1? It means we're going down 1, but we're staying the same column-wise. So that will be this cell right here, C22. And that is going to set that equal to 3 times I. Now what's 3 times I when I is equal to 2? 6. So it should output 6 there. And as it does, right? So if we keep going through that, we can see that it starts outputting the 3 times tables, right? And then once it reaches the end, it exits the sub. So we'll remove the breakpoint by clicking on it, and you can see that's how this code works. Now, once you get really experienced, of course, you no longer have to put in the breakpoints, but it's good when you're learning because it really shows you how the program is working inside, okay? In this one right here, you have to count from 7 to 77, and of course that's just the 7 times tables, right? So that shouldn't be too difficult. It's pretty much the same thing as what you've done in this one right here. Now let's move on to the next sheet. Okay, so this sheet right here is a little bit more challenging, but it's still not that challenging. So rather than doing the code, I will tell you what you need to do. Actually, hang on, let me have a look at what you have to do later on. Yeah, I'll sort of talk you through this one, but I want to demonstrate this one because this one's a little bit harder, okay? So we'll start with this. Now, what your task here involves is basically just taking the return here and then copying it into here, okay? So what you want to start with is you want to start with a loop for I is equal to 1, 2, 6, 4, 9, 3. You've been told that that's the total number. And then for each one, all you want to do is range B7.cells I, 1. Okay, so for this next sheet here, I'll just talk you through what you need to do rather than actually doing it because I think this is very easy once you've gotten the hang of for loops. So again, if you look at this sub here, sub for loops 2, we'll use this as sort of a model as to how to solve this problem right here. Okay, so we'll have for I is equal to 1 to something, okay? And that something is how many times I want to repeat this. Now, we've been told right here that there's 6,493 values. So we want to repeat that 6,493 times. So it'll be for I is equal to 1 to 6493. Okay, that's very easy. Now, what are we setting equal to what? Okay, that's the next question we want to ask ourselves. So remember that in programming, it's always what is after the equal sign being set to what is before the equal sign. So what is before the equal sign is the output, and what is after the equal sign is the input, okay? What is the output? The output here are the cells from E7 going down, okay? So the output are cells in this column right here. The column stays the same, but the row changes. So essentially, it is range E7.cells, open bracket, I, 1. Okay, and now why are we using I, 1? Because we want the rows to change, but we want the columns to stay the same as 1. So the columns never change from cell E7, right? And what is the input? Well, the input is the same thing, except we're not taking from cell E7, we're taking from cell B7. So we just want to take what is in B7 and put it into E7. So remember that it is output equals input. So it'll take what is after the equal sign and put it what is before the equal sign, okay? So what is before the equal sign is this set right here, and what is after the equal sign is this set right here, okay? So use the Range.Cells command, and again, you just reference the original cell and then use the subscript I to then go in and move down as we've been doing in the previous workbook. Previous sheet, sorry. Okay, so let's move on to for loops 3, and this one is starting to get a bit more challenging, so I think this one will be a bit more fun to try and really tease out and see how it works. So what we're being asked to do here is to calculate an average, and of course we can do this very easily in Excel using the average command, okay? And we'll have to go down a while. Okay, and that is the average that we want to calculate. So if we get a value that is equal to that, we know that it's right, okay? Now we have to do this using a subroutine and using a function. Now, I've gone through this before. The difference between a subroutine and a function is that a subroutine is very specific. It takes a very specific input and outputs to a very specific place. So it's good when you want to do repetitive tasks that have the same input and output cells. Functions allow you to input what you want and to output what you want, okay? So let's do this using a function, though I probably think I should use a subroutine as well, but I'll think about whether I should do that or not. So we'll start a function by inserting a new module. So that's how you create a function. You have to put into a module, and we'll call this function function for loop average. Okay, and that's where we start. Now, inside the brackets here, remember that's where we put our input. So let's think about what we are actually inputting into this function. What we're inputting into this function is no longer one value or two values or three values. It is a series of values, okay? And that series of values is what is called a range. So it doesn't really matter right now, but let's just call that input INP for input, okay? And now we'll go into the body of the code here and we'll think about what exactly we want to do with INP. Now, when INP, this entire range here from B9 to B6501 is passed into this function right here, it'll be passed as basically an Excel range, okay? So we need to somehow parse that Excel range into an array, okay? So let us first define an array, okay? And we'll define that array and we'll call it, let's say, input array, okay? Okay, so I've defined the array, input array, and notice that I haven't put anything inside the brackets because we don't know how many cells there are going to be, right? Well, we know that there are 6493, so I could just put 6492 into the brackets, But that's a bad programming idea, because what that does is it limits the code to only work with 6493 values. So what we want is we want to write general code that can calculate the average in a very general sense, okay? So we'll start with just defining the array. Now, what do we want to do next? So think about this for a second. What we want to do next is that we need to find out how many values there are. So a good place to start is just to define a variable which we can store that in. So let's define no rows. Oops, it should be, yep, no rows as integer. Okay, so it's going to be a count of the number of rows, and it's going to be an integer. Now, we have our input INP, okay? Now, the command which returns the number of rows in INP is as follows. So no rows equals inp.rows.count. Okay? So essentially what this does right here is it takes inp.rows.count, and this command returns the number of rows in INP, and it takes that value and puts it into no rows, okay? And now we want to change our input array to have no rows minus 1 elements. Remember that arrays start counting from 0, so you always want one less than what you actually have, okay? So let's say redim. Okay, so the redim command allows us to change the dimensions of our previous defined arrays, okay? Of course, the other way we can do that is, of course, we can just put this after and put no rows into the brackets, but I prefer to do things this way because it gets things out of the way. So we know what we have to define first, and then we progressively move on, okay? So now we have an array which has the correct number of rows. Now we want to input the values in the input into that array, okay? So what we're going to do is use a for loop to do that. So for I is equal to 1 to no rows, next I, okay? So always start with the syntax of the for loop, and we're starting from 1 and going to the number of rows because we want to input each and every row into this array, okay? Now, remember that arrays start at 0 and I starts at 1. So, input array, no rows, oops, not no rows, I minus 1 equals, okay? So, the reason why we use I minus 1 in here is because we want to input the first element into element 0 of the array. Arrays start counting from 0. You really need to remember that. So, the index that we use is I minus 1. Now, what does that equal to? It's going to equal our input. Remember that we're writing a function here, not a subroutine. So the input is not whatever is here. The input is what's in here. So the input is what Excel passes to the function, not necessarily wherever the input comes from, okay? So it's going to come from inp dot cells, open brackets. Now, remember how we've used the .cells command in order to refer to particular cells inside a range. Now, instead of starting from any particular cell and counting down, what INP does is, I've told you before, it passes this entire range into the function, okay? So INP refers to whatever Excel passes into our function. So INP.cells, just like we've done in previous sheets, now it's going to be rows, comma, columns. Now rows is what changes, right? So row is what we want I to be. Column stays the same. We can see the columns don't change. So we want columns to be 1. All right, easy enough. And we'll save that. And what this does is basically it inputs this into our input array, okay? So that's the first for loop. So after this for loop, what we have now is an array with I minus 1 elements, and, well, not I minus 1 elements, it should be I elements starting from 0, so it has a final element of I minus 1. And we've input whatever our input is into that array. Okay, now we can do whatever we want with that array. Now, to calculate an average, what we have to do is sum everything up. So in order to sum everything up, let's think about that mathematically. What we do is we take element 1, we add it to element 2, and add it to element 3, and add it to element 4, and so on and so forth. So we need some sort of a total, right? So let's first define a total as a double precision number. So we're going to say dim total as double, okay? So we now have a value where we can, well, not a value, we now have a variable where we can add up our values inside our output array in order to find what the total is. And now we know that we want to do something iteratively. And when we do something iteratively, we use a loop, okay? So a good place to start again is to use a for loop. So we'll go for I is equal to 1 to no rows, next I, right? That's a great place to start because we know that that's exactly where we want to begin. So total equals, and now we write total equals because we know that that's what we eventually want our output to be. Now we want total to equal the original value of total plus the next iterative value, okay? So we'll write total is equal to total plus. So what this is telling VBA to do is basically take the original value of total and add in the next return, and that will return the final value of total, and that's what we want to do, right? And we want it to add input array I minus 1, okay? So what it does here is basically input array I minus 1 now is this series of returns, I guess, okay? Now total will start at 0 because we've defined it, but we haven't really initialized it with any values. So total starts at 0. So the new total is going to be 0 plus input array I minus 1. Now when I is equal to 1, this is going to be input array 0, which is this value right here. So it takes this value and it adds it to the original total, which is 0. So now total is just this value here. So in the next iteration, it'll take this value here, which is the original total, plus the next value, and that will give it the new total. So the new total is this sum here. And then it takes this sum, the original total, and adds it to the next one, and the next one, and the next one, and so on and so forth, until this entire loop is done, until it reaches the number of rows, okay? Now, the average is very easy to return from here. The average is just the total divided by n, or the number. So the average is very easy to return from here. The average is just the total divided by n, or the count. So all we have to do is for loop avg is equal to total divided by no rows. Okay, and the reason why we do that is, remember that when we want to return a value, we set it, we set the function name equal to that. So we are returning total divided by no rows. Of course, no rows is the number of cells in the input, so we just take our total divided by the number of cells in the input, and of course we should get our average. That is quite logical. Now we can call our for loop from here. Okay. So we should note here that this is B9 to B6501. So we can call our function here for loop avg B9 to B6501, okay? Or you can just drag down as we did originally. Press enter, and you can see that the average has been correctly calculated. Now, that's not interesting though, right? We want to see how this actually works. So how about we go into the function right here and see how the program steps through this function in order to get our answer. As we did before, we can just simply put a breakpoint here right at the start of the function, and we'll see how it works by stepping into the function. So we want to run it again just by clicking here and pressing enter, and you can see that it goes here into the function. Now let's see what it does. So first of all, it simply defines input array and number of rows, right? And what we can actually do is we can, it'll go straight to here because these are just defining variables. There's nothing much happening there. And we can see that number of rows starts at 0 because we haven't put a value in. Remember that when it highlights something, that's the next to go, not the one that's just been done, right? So let's run that line of code, and you can see that number of rows is now 6493, okay? So 6493 is the number of values, and it's correctly put that into number of rows. Now we simply redim input array with number of rows, and we can see number of rows is 6493. Okay, so I am making this little update because I realized that I made a small mistake, but it doesn't really affect the quality of the code or the fact that it works or anything. But it's a point that I should point out is that instead of having input array no rows, it should be input array no rows -1, for the same reason that I've been explaining that arrays start from 0. So I even get confused by that sometimes, but it's important to really remember that arrays start at 0. So you always sort of have to have that -1. So I'm just making this little update to point that out, but it doesn't really matter. It still works even if you don't have the -1, but it's good practice to correctly define these things. So we'll change that to -1 now, and then we'll go on now to see how the code actually works by using a breakpoint. So if we put in a breakpoint there and run the code, we can see that now we're allowed to step into the function using the F8 key like we did previously to understand how this works. So let's step into here. You can see that this is just defining two things, nothing really important, and here is where the code really starts. So you can see what it actually does here is it sets no rows is equal to this. So no rows is now 6493, which is the number of values that you're inputting, right? So that's as expected. Now, what we're going to do here is redimensionalize input array to no rows -1, where no rows is 6493. So no rows -1 is 6492, okay, as we know. So basically it'll put redim input array 6492. So it just substitutes in no rows into that place right there, which is 6493, 6493 -1, 6492. So that's easy. And now this is where it really gets fun. So it gets into the loop, and what it does is it goes for I is equal to 1 to no rows, which is 6493. It's going to take input array I -1 is equal to input cells I, comma 1. So it's going to take this here and put it into the array. So if you run this, you can see that it's going to do this 6,493 times. So it's just taking input cells I, which is now 4 because we've run it 3 times already, and it puts it into input array 3 because arrays start counting from 0, okay? Okay, so from here, of course, I can just run this 6,493 times by just holding the F8 key, and it will go and go and go and go and go. As you can see, it's doing right there. But that's really slow, right? You don't want to do that. What you can actually do is, let's say you put a breakpoint here for I is equal to whatever. What you can actually do is, I don't know what it's up to right now. It's up to 180, so you're going to be sitting here for a long time if that's only 180. But you can just use the step out command, and step out allows you to step out of the loop, and it just proceeds as if the loop has gone 6,493 times, whatever. So we go step out, and it'll go to the next breakpoint. Notice that I had to put the breakpoint in there, because if I didn't and I use step out, it'll just continue on to the end of the function, right? So we've stepped out to this particular point right here, and what this is doing is just going to add. And what is this doing here is what this is doing here is going to add the input array values into a total. Okay, so we'll see what it's doing by using the F8. So it's gone through the loop once. Total should be 0.032835, which is that. So it's 3.2835 times 10 to the power of -2. So it uses scientific notation, but you can see that it's right. Okay, now if we go through again, we can see that that I is now 2. So it's taking input array 1, which is the second element inside that array, and adding it to the total. So total is still the first value. And now if we run that, we can see that total has now changed to 2.15 times 10 to the -2, which is this plus this, right? You can take out a calculator and check. And of course, you can just run that again and again and again and again. But and you can see that it'll consecutively, iteratively add on each of these values. Now I'm going to set another breakpoint here and just simply step out, and it'll go here. Now for loop average is going to be empty. It hasn't run this line of code yet. So what it's going to do is take the total, which is this 1.93 or whatever, and divide it by 6493. This is what an average is. It takes total divided by the number of samples, and we run that, and then we're at the end of the function. So we can see that once we reach end function, it'll output that value into this cell right here, and we have the same value as the average as required. Okay, we'll go on to the next sheet now. Okay, so what we have here is now we're going on to nested for loops. So for loops are useful, but so far we've only been able to do one-dimensional things with them. Oh, I guess we sort of did something two-dimensionally when we went diagonally, but a diagonal line is still a line. It's not really a two-dimensional shape, right? So in this example right here, I'm going to show you how you can view a table or any two-dimensional object as just a series of one-dimensional objects, okay? So what we want to do is count from 1 to 10 5 times. So let's really look at what that looks like. Whoops, that was too far. Okay, so that's what that looks like. So what we're really doing is we have a one-dimensional loop counting from 1 to 10, just going down the columns, and then we have another loop which repeats that loop 5 times, right? So what we're doing is we're taking this one loop here and we're repeating the entire loop 5 times across the different columns. So how do we do that? Let's start with a sub, okay? And we'll call this sub nested for loops. Probably should put a 1 there because we're going to do this multiple times, right? Now, first of all, let's simply try and put 1 to 10 in the first column. That's simple enough. You should know how to do that. So for I is equal to 1 to 10, range, whoops, next I. So always start with the syntax and then put whatever you need in the middle. So that is range G6 dot cells I comma 1 is equal to I. Okay, that's exactly the same as what you've done in the previous sheet. And if you run that, no surprise, you get 1 to 10 in the correct place. There you go. Now, how do we repeat this across each and every different column? Now, for a second, let us just treat this entire for loop as just a black box of code. It doesn't really matter what's inside it for now. What we want to do is we want to put another for loop outside of it, except we can't use I. So this time we'll use J instead of I. So I is just a count, right? But this time we'll use J instead. So let's say for J is equal to 1 to 5. Next J. So what we're doing here is we're saying, and we'll indent this so we can see that this is clearly inside this outer for loop. So we want to know, so we know that we want to run this interior for loop right here, and that for loop, all that does is put 1 to 10. We want to run it 5 times, okay? Now, it doesn't really matter what's inside here. We can treat that as just a black box. We can just treat that as some code which puts 1 to 10, okay? We don't really need to know what that code is. So we have some black box of code, and we run that 5 times in order to put 1 to 10 in each of these 5 different columns. So what are we going to do? If we do this, we don't have J anywhere inside this loop here, okay? So it's just going to run the same thing, except it'll put 1 to 10 in this column just 5 times. So it'll just run it 5 times, overriding what it did the previous time. But think about what we're changing now. So before, we were only changing I as we went along, but now we also want to change the column, and we want that to be equal to J, okay? So we'll put this equal to, actually before I do that, what I'm going to do is just quickly create a sub and clear it. Just going to quickly create a sub and clear it, okay? So if I run this code right here, it should clear that. All I've done is just use the previous code, except do this little thing here, which is setting all these cells to an empty string, okay? Don't need that anymore. So I will delete that. Okay, so now we want the rows to be I, but we want the columns to be J, okay? So we'll change this to IJ, and it'll be really clear in a second why. Okay, so in order to understand nested for loops, let's use our our debugging or our breakpoint technique to sort of understand what we're really talking about here. So put a breakpoint here, and I'll just press F8 twice to go to the start of the loop. And here I is equal to 1, J is equal to 1, and I here again is 1. And of course, everything is 1 because this is the first time we've run either loop. So if we go through, we can see that it inputs the number 1 into that particular cell right there. Now, you can see that it just repeats back, but we haven't exited to the outer loop yet. So this is still the first time this outer loop is running. So think about this inner loop here as just a black box, okay? This inner loop here hasn't finished yet. It still needs to go 10 times before the first iteration of the outer loop is complete. So j is still equal to 1. See? But I, because we've already gone once, is now equal to 2. Okay? So this is just going to put range.G6.cells and substitute 2, 1 into here is equal to 2. And what that's going to do is that's going to put the number 2 into this cell right here, which is G6.cells 2, 1 as required, right? And now let's keep doing that, and we can see that it repeats through and it goes all the way up to 10. Now when this reaches 10, this condition is satisfied, therefore it'll exit the loop, there you go, and go next j. So essentially what's happened here is this inner loop, if you view that as a black box, has just finished. So that's finished once. So this is going to go to the next iteration of the outer loop. Now if you go back to here, you can see that j now is equal to 2. Okay, so if you step in here, I will equal 1 again, because this is the second iteration that the outer loop is running, and it just resets the inner loop, and it's going to do this 5 times. So you can see that I is now 1, j is now 2, and I here is 1. So what it's going to do is range G6.cells 1, 2, which is this here, because it increases the column by 1, the rows is still 1, so it's going to be 1 across from G6, and that's going to set it equal to I, which is 1 in this case. Note that every time the outer loop runs, it resets the inner loop, right? It only changes j. So let's keep running that. And you can see that it inputs all the way up to 10. And then now you go back out, except we have j is equal to 3 now. So this is the third time the outer loop is running. And you can just do that, and you can see how it inputs it by running this code that puts 1 to 10 in one column. So what it's really doing is, I'll finish this up, okay, end sub. All right, done. And turn off the breakpoint. But what it's really doing here is you can really see that it's essentially just taking this code which puts 1 to 10 and running it 5 different times such that you get 1 to 10 in each of these 5 different columns, which is given by the letter J. Okay, so that's it, and we'll move on to the next task. Now instead of doing this task is really easy. This is actually not difficult at all. Hang on. Okay, so I won't do the average and stuff, but I'll do this one, because this one is I think this one's important to do. So we'll do this one and we'll call it sub nested for loops 2. Okay, and again we want to run a certain loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 5. Okay, so we want to copy each of these rows, and we want to do that 5 times. So let's think about what we're doing. One loop will allow us to either copy one row or one column. Okay, so what we're doing is copying this column into here and copying this column into here, and so on and so forth, right? So what we're really doing is we're essentially just saying we're going to copy columns, and we're going to do it 6 different times. So I said 5, well, there's actually 6, I didn't count. And we're actually going to do that 6 different times, right? It says here that we want to load it into an array first. So let's do that. Let's define an array. Okay, and we don't know how many elements are going to be in that array. So we just leave it blank. This is a subroutine, not a function, so it's only specific for this task. So what we can do here is simply redefine the array for it to be a rows by column, so 10 by 6 array. Now notice that 10 by 6 will be 9, 5. Okay, so we're going to redim ret to be 9 by 5. Okay, and notice that arrays start counting from 0, so that's really 10 by 6. Okay, Now we're going to have an input for loop. Actually, you know what I'll do? I'll start with I, and you'll see what I'm doing in a second. Okay, so we've started here with I, and what you see I've done is essentially, this is the inner loop. So we'll try and figure out the inner loop first, and then we'll modify it to have the outer loop inside it. So what we're trying to do is put this value right here, or these series of values, into ret r, okay? So, whoops, so we'll go here at ret r, I, comma, 1. We'll start with just 0, actually. Is equal to range, and that's B22.cells I, comma 1. This should be I minus 1, okay? I really need to stop making that mistake, but arrays start at 0, so the index, so it's different to the cells. This is the confusing part, right? But the cells count from 1, but the arrays start from 0. So either you have to do I minus 1 here, or you can also count from 0 to 9, but then you have to use I plus 1 here. It doesn't matter which way you do it, as long as you get it right. So this right here will input these values into the array. But that's not what we want. We want to do that 6 times, okay? So we know that on the outside of that, we're going to have for some j's equal to 1 to 6, because we want to do that 6 times. And of course, remember that when you use a for loop, you have to have a next j at the end. And we'll indent this to show that that is happening inside the for loop, inside this outer for loop. So instead of having 0 here, we now want the column index to be j minus 1. Same logic as to why we use j minus 1, okay? And instead of having 1 here, we want that to be j. So this code right here will input this into the returns array that we've defined, okay? That's easy. Now we want to take that returns array and output it to here. So remember that it's always what is after the equal sign being put into what is before the equal sign. So what we'll actually do is we'll just copy the same code, because it will just be the same thing, right, to output it, except this here will be different, right? So what will this here be? So what are we outputting to? We're outputting to range B42.cells, okay? And it'll be I, comma j, so rows by columns, just the same logic as we've used here for B22. And what that's going to be equal to is just this thing here. All right, so we just copy that. Whoops, I think I pasted, copy, and then paste that right here. And what that's doing is taking returns array I minus 1, j minus 1, and then putting it into range B42 cells ij. Now let's run it, and you'll see that it has successfully copied the values here into here. Okay, so you can do the rest by yourself. That's all from me for this week, and good luck. Remember to submit, and thank you for watching. See you in the next one.